Other properties of exponents are, for example, if I have the square root raised to the power of n of a certain value, that will be the same as saying a to the power of 1 over n. So if I have the square root of x to the power of 3, that will be the same as saying x to the power of 3 over 2. Or if I have the cube root of y to the power of 1, or just y, that will be the same as saying y to the power of 1 over 3. So in case of the square root, the value inside of the root is 2, and we'll divide the exponent on the inside with 2. And in the cube root, we'll divide the exponent on the inside with 3. And this would be valid for any other form. So let's say, for example, we have the root form of 4, and we have x squared and y to the power of 3. So if I want to remove the root, this can become x to the power of 2 over 4 times y to the power of 3 over 4. And I can simplify the exponent of x. So that becomes x to the power of a half times y to the power of 3 over 4. But notice that I divided the exponent on the inside with the root form on the outside. Other properties that we have learned is anything raised to the power of 0 is equals to 1. And if I have a to the power of negative 1, that's the same as saying 1 over a. So if I have x to the power of negative 2, that would be the same as saying 1 over x squared. And if I have, for example, 1 over a to the power of negative 1, that would be a to the power of 1. So let's say, for example, I have 1 over y to the power of negative 3. That becomes y to the power of 3. So what we see is when we have a negative, that creates a fraction. I could write 1 over the variable to make the exponent positive. So in this example, we had x to the power of negative 2. And I write 1 over it, so it becomes x squared. And that's how I make the exponent positive. And the reason why we need to be able to do this is in algebra, we always want to leave our answers in positive exponents.